Okay, so recognize the basics of networking, describe virtual networking in the cloud with Amazon VPC, label a network diagram, design a basic VPC architecture, indicate the steps to build the VPC, identify security groups, create your own VPC, and add additional components to it to produce a customized network. Identify the fundamentals of Amazon Cloud 53 and recognize the benefits of CloudFront. Okay, good. Section 1, networking basics. Now, we have a network here, right? We have a router. You know, the router is the one that, connects networks, right? A switch would connect computers, a router would connect networks. So we have here subnet 1, subnet 2, and then we have 3 servers here, 3 servers in every single uh, every single section. Okay, subnet. A subnet is a section of a network. It's a fragment of a network. Okay, so here we have, 4 octets. Um, an IP address is divided in 4 octets. It's a total of 32 bits, right? Every number that you see there, 192.0.220, that is 1 bit, right? 1 bit. And the entire thing is a byte. Okay. So actually it's 1 byte, not 1 bit. Sorry. This is 1 byte, right? This is 1 byte, 1 byte, 1 byte. So it has 4 octets. Okay. 4 octets. Okay. So you have, you say 1, 2, 3, 4, 5, 6, 8, 7, 8. So that's a byte, right? That has 8 bits, right? 8 bits is a byte. 8 bits is a byte. Is a bits is a byte. So in total is 32 bits, right? So the computer doesn't read 192. The computer reads 11111000000. Okay, the computer doesn't read numbers or letters. Computers read binary. So 0 or 1, 0 or 1, 0 or 1. All right, you don't need to know that for now. Like I said, this is not a networking class, right? But what you have to know is that every single component before a dot in an IP address, it's a byte, okay? That has 8 bits, okay? And in total would be, 32 bits. That's an IP for IPv4 protocol, IPv4. IPv6 has 128 bits. As you can see here, it's in hexadecimals, okay? It's even more complicated, but, they have more reserved slots from this guy here because unfortunately they are running out of IPv4 IP addresses. So they have to come up with the IPv6 protocol to be able to have more. So here there are billions and billions of addresses. So there's going to be a long time before we run out of IPv6 IP addresses. And of course, AWS is prepared for this change here. So Amazon already is, it's prepared for that. So let me show you something here. A class that I'm teaching during the day. It's a Linux class. So I have this here. This let me just get out of here. Okay. So if I do this guy here, if I do this command, ns lookup, and I do AWS.com, I get this information here. And we don't have that. It doesn't have that. It doesn't offer here an IP address like IPv6. Okay. So, like I said, a computer doesn't understand numbers, and the computer doesn't understand AWS.com. The computer doesn't understand that. What the computer understands is an IP address. At the end of the day, an IP address is 32 bits, right? This is what the computer understands. It doesn't understand names like Amazon.com. Okay? So there are many websites around, companies that are accepting this guy. All right, the IPv6 protocol. Okay, so here we have a network identifier. That's we have the routing prefix and the host identifier 24. Okay, so this tells you how many IP addresses can you allocate, right? So when you start from 32, right? If you start from 32, let me see if I can connect. One moment. Give me 1 second. Okay. One moment.
Echo.
Okay, just give me 1 second, please. Okay, so we have. Just give me 1 second. So we have this. When we have 32, that's only one IP address. When we have 30, that is two IP address. No, I'm sorry, not 30, 31. Okay, when you have 30, that will be 3.
By the way, that's a slash, not a 132.
I'm sorry?
Slash 32 slash.
When we have 30, I'm sorry, 29, sorry, we have 8. When you have 28, we have 16. When we have 27, we have 32. When we have 26, we have 64. When we have 25, we have 128. When we have 24, we have 256. So right now, the one that it is in my screen, it accesses 256 IP addresses. Okay. So I'm gonna go back to this, to my screen. Okay. So right here, we have, it tells you how many bits are fixed. Okay, so fixed is 256, right?
We can't see the screen.
Okay, sorry.
Yeah, we cannot.
Can you see now?
Yes.
Yeah.
So this only accepts fixed 256 addresses. Okay. So the further down you go, the more it will accept. Okay. Until it gets to 116, it's going to be 65,000, 65,536 IP addresses. Okay. So the smaller the number, the more IP addresses it accepts. So as you can see, it doubles, right? So 32 was 1, 31 is 2, 30 is 4, 29 is 8, 28 is 16, 27 is 32, 26 is 64, 25 is 128, and 24 is 256. So it goes, it doubles as you go down in the number. From starting for 32, which is only one. Okay. So we have, this is fixed, 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 and this is flexible. And that's going to be 256. Remember, the number that's going to show here is not 256, it's 255. Why? Because it starts from zero. Zero is a number. So if you go from 0 to 255, that's going to be 256 IP addresses. Okay? So the highest the highest the number it can get is to 255, and the lowest is 0, from 0 to 255. Okay? So as it goes here, this is flexible, 256, right? And then as it goes down, 223 would be 1024. Okay, 1012, right? 1012. Yes. Then this is going to be flexible too. So it's going to be 256 and 256. Okay, not 512, not 1000, 512. Okay, and then 1024. That's double. Okay, so if it is 24, like I said before, it's going to be 256 here. If it is 23, it's going to be 256 here, and in total, it's going to be how many? 512. Okay, so that's how it works. Now, this is the OCI model. So you have 7 layers, right? The 7th is the application layer. It means for an application to access a computer network, right? And when we see the elastic load balancers, you're going to see that the application load balancer works on this layer, in the layer 7 application layer. The presentation layer is number 6, ensures that the application layer can read the data and encryption. Okay, and these are the protocols. Okay, the session layer enables orderly exchange of data. Okay, the transport layer is for, it provides protocols to support host-to-host communication, TCP, UDP, the 2 protocol for transport. Okay, now this is where the network elastic load balancer works on. It operates on layer number 4, the transport, and the classic elastic load balancer, which is the old one, operates on both 7 and 4. Okay, now the network layer is number 3, is where you see the routing and the packet forwarding. You see the routers, the switches, all the routers, the switches in the next one. The routers are in this particular layer. And then you have the IP, okay, Internet Protocol. The data link is layer number 2, transfer data in the same LAN, local area network. So we have the hubs and switches, devices for connecting computers, you know, in the case of a local area network, right? You have the MAC address there, the address for that, okay? And then you have physical, the number 1 layer, is for transmission and reception of raw bit streams over physical medium, signals, 1s and 0s, binary, okay? So this is just a taste of networking. You don't have to become an expert in the OCI model, but you know, it's good to know this if you're furthering your education. And then the network component is going to be a little more difficult and in depth. Okay. Amazon VPC. What is the VPC? VPC enables you to provision a logically isolated section of the AWS cloud. So it's a little section, right? It's a little portion of the AWS cloud, dedicated only for you guys, right? And it's logically isolated because it is not depending on any other VPC. It's logically isolated. Now you can connect VPCs, right? You can have something called VPC peering, and then you can peer the 2 VPCs and have the resources inside the VPC connect with each other. Okay. Now, here you can launch AWS resources in a virtual network that you defined. Okay, you define the CIDR, You define the subnetting. You're the one that works on that. Okay, that's your responsibility. It gives you control over your virtual networking resources, right? Including selection of IP address range, creation of subnets, configuration of route tables and network gateways. So that's something that you guys do. It enables you to customize the network configuration for your VPC. So it's good practice whenever you create a VPC to create a CIDR that allows a lot of IP addresses, but you have to be careful. You don't want to waste IP addresses, right? So it's good to start with a higher range because you don't know, or probably your business grows and you will need more addresses. And let me tell you something, when you create the VPC and you establish your CIDR, which is the class interdomain routing, the classless interdomain routing, once you establish that CIDR, you cannot change it after you create it. So you're gonna have certain amount of IP addresses that you select when you create the VPC, your VPC network. If you, for some reason, if you create less than you need, you're gonna have a problem. You will have to recreate the VPC. So be careful with that. It enables you to use multiple layers of security. VPC is secure, it's very secure, but you guys have to put the security in place, right? VPCs and subnets, logically isolated, like we said before, from other VPCs dedicated to your account, belong to a single AWS region, right? It's a region-based resource, and it can span multiple availability zones. That's possible. Like this one, for example, you have a VPC here that is, it expands, two VPC, two AZs, right? AZ1, AZ2, and you have one subnet here, one subnet in the other availability zones, and all of them are inside one region. Okay. Now you can have multiple VPCs inside one region. Okay. But they are inside the region. They're not outside the region. They're not a global service. They are a region-based service, right? Regional service. You can have a VPC for HR. So you can have a VPC for developers, designers. So VPC could be an option or an alternative to AWS organizations. So you have a choice. You can have multiple VPCs architecture, or you can have an AWS organization. So that is, choices that you guys have. Okay. Subnets is a range of IP addresses that divide a VPC. So what would you use a subnet to fragment your network and organize it? Okay. Use a net. You can put the private subnets, right? You can have a private subnet, and there you can put the database, right? Something that doesn't have a connection to the internet, and no one can access your database because it is in a private subnet, right? So there's something called internet gateway. That's what connects your subnet or your resources inside the subnet to the exterior world, through the internet. So that's the internet gateway. What makes a subnet private? It doesn't have a connection with an internet gateway. That's what makes a subnet private. Be careful with that. Your question, you may have a question in the exam asking you what makes a VPC or subnet private. Okay, it is private because it doesn't have any internet gateway attached to it. Okay, the public one is the one that has that. Okay, so a subnet belongs to a single availability zone, right? You will not have one subnet in different availability zones. Okay, the one that spans across availability zones is the VPC, right? The subnet is for one availability zone, and they cannot overlap. Okay, they cannot have the same number, the same IP address. They have to be different. Okay.
So I have a question. So I have a VPC, I create a VM, But then I want that VM to have outside access to the internet.
Right.
Do we then allow that VM individually access out to the internet?
You put it in the public subnet, and that's it.
Public subnet. Okay, so you cannot have it private and then
Of
open up.
course. And of
or-
course, you have to leave open port 80 and 443 for access to it, right? And it will have access to the internet because it is in a subnet that has an internet gateway. Okay. If you don't want your server to have access to the internet, then you put it in a private subnet.
Private subnet, okay.
Okay. When you put it in a private subnet, it will not have access to the internet, and the internet will not have access to it. Anything coming from outside will have access to that. It will have to go through a proxy server to be able to connect to the internet. Okay. And of course, you don't want that, right? What you have to have is a NAT gateway, and then and a NAT gateway or a NAT instance. Those are the ones that let that server in the private subnet to communicate with the internet. So then we have to go through the NAT gateway. Okay, is the network address translation.
So I
That's
have a question. So, okay, so I've never had to do that in my years of IT. I've always relied on the network administrator, which has the big picture of this whole thing. Is now become a responsibility of the cloud engineer to do this?
correct. Everything inside the cloud is your responsibility. So everything that is done inside a VPC, it's your job. Okay. The architect has to create a VPC, put the servers in the respective subnet, depending on how secure you want it to be, right? And you have to make the connection to the exterior, to the outer world, okay? And you have to have a bastion host or a NAT instance or a NAT gateway for those servers in the private subnet to be able to download updates, patches, things that you need from the internet. But they will not be able to connect directly to the internet. So you have to make sure that that's the way it is. If you don't do it that way, you may have some problems because you're supposed to put whatever is confidential and whatever is supposed to be secure in a private subnet, not in a public one.
Now, in case of a latency between subnets and between machines, etc., and we find out it's not our platform, it's your platform, do we call you to resolve issues with latencies and network related? Or who monitors this network?
You mean you call me?
I mean, we call Amazon.
Oh, no. Latency? Oh, latency? Well, that will be probably Amazon. Yes. Because Amazon is responsible for the security of the cloud. So whatever has to do with the outer world, making sure that things are faster than normal, faster, they're fast, not faster than normal. They're fast and they don't have latency. So everything that depends on Amazon, then you have to consult with Amazon, right?
So is there like a sharp wire? Is there like a way of monitoring between availability zones that is not related to my load, but it's network? Is there tools that are similar to in the on-prem world to see where the bottlenecks are to
Yeah. Sure. The VPC has logs, right?
Yes.
It has logs that will tell you what's going on. Okay. Everything's going on. The last load balancer has logs. Okay. So there's going to be a lot of logging in between, telling you what's going on, the speed, and if something is wrong, you can call Amazon, tell them what's going on. Okay. And I mean, everything should work normally if there's no issue in the dashboard, in the health dashboard. Remember we saw it. Everything should work normal. Okay.
Okay.
So classify as public or private. That's the subnet. Okay. When you create a VPC, you assign it to a IPv4 CIDR, range of IPv4, IPv6 addresses code. The highest it can go is /16, and the highest, the slowest, the smallest it can go is /28. Okay, that's how you create the CIDR in a VPC on Amazon and AWS. Okay, those are the limits. 16 is the highest you can go. Remember, the lower the number, the highest the amount of the number of addresses you can have, right? So the maximum is 16, the minimum is 28, which is 16 addresses. Okay. You cannot change the address range after you create the VPC. I said that already. Okay. Be careful with that. The largest IPv4 CIDR block is 16, which is 65,536. And the smallest IPv4 CIDR block size is 28, which is 16 IP addresses. IPv6 is also supported with a different block size limit. Okay. CIDR blocks of subnets cannot overlap. So it means that, let's say, so let me come here. Let's see if I still have access to this. So I come here where it says VPC. And then I want to launch the VPC wizard. Okay. So this is the highest you can go. You can put here 28, right? And that's gonna be 11 IP addresses. Why 11? Do you have an idea? So do you have an idea, guys? Why 5? Why 11? Because by default, Amazon takes 5 IP addresses. So Amazon will take 5 IP addresses. That's why you have 11 instead of 16. Amazon always takes 5. That's standard. Okay? Oh my God, I don't know why I always lose control.
We're gonna send you a mouse for Christmas.
No, the mouse works perfectly, but it's always here when I am in the AWS console. If I get out of it, it works. Look at this. It works everywhere except here. I don't know why.
Apple computers.
Robbie. So I have this guy here, 16, right? And then I'm gonna have here 24. Okay. So they cannot, my new VPC, Miami-Dade College. Okay. So I have here 10.0.1.0-24. Every single subnet has to have a different IP address. So if I create another subnet, it has to be like this. If I do another one, it has to be like this. Okay. This is the section that defines the subnetting. Okay. I cannot overlap. If I try to create this one again, it would tell me that it cannot overlap. Okay. So that's going to be my first subnetting. Okay. But I'm going to do that. When I create the subnet, I will be able to change this. But this is the CIDR for the subnetting. This is the CIDR for the VPC. Okay. So now, I will do this here. I will create my VPC. It's create this. These people have improved this so much. This looks much nicer than before. Okay. So I have my first VPC here, right? It's right here. So now that I have my VPC, I have the flow logs here. Okay. I can create the flow logs and have my information there. So I can create a subnet here. Okay. Look at how many subnets I have here. So I can create a subnet here and I can call it, let's say, subnet we'll publish subnet. So it's good practice to have at least two subnets per availability zone. Okay, one public and one private. Okay, so publish subnet 1, I'm gonna just put it in my new VPC, Miami College. And then the CIDR of this subnet is gonna be 10.0.1.0.24. Okay, and then now I'm gonna create this subnet. So I have my subnet here. Let me see the name of this subnet. Okay. So let me see the VPC here. Is this one here. So I have this guy here. Let me rename this guy. So I'm gonna say subnet, publish subnet. Let me put this 1. And this, let me put it 2. Okay. Still, this subnet is not public. I haven't attached the internet gateway yet. Okay. So now I create another subnet and I call it private subnet 1. And then the VPC is going to be the same. The CIDR, I can put this in any availability zone I want. Okay. So for now, I'm not going to do this. So now the CIDR is going to be 10.0.2.0, and this is 24. All right. Then I create this guy. I can do this from the CLI if I want to. Okay. But I'm doing it from here. Okay. So now the private subnet 2, and then I'm going to put it here, and then I'm going to say 10.0.3.0, and then 24. They cannot overlap. Okay. Now I have the 4 subnets here, right? There are 2 here and 2 here. And I want to delete, let's see if I can delete these guys here. Okay, let's see if I can delete them. These are the ones that I created. This one by default with the default VPC that I created when I create my account. I don't want to delete those. Okay, so I can delete the subnet and they're gone. Okay, now I have my 4 subnets here, right? So I have an internet gateway here that is already created for me, right? This one is attached to this VPC here, okay? And this one is attached to, let me see here. There's one attached here, okay? So what I have to do is probably go back to the subnets and come back here to the publish subnet, right? Let's say number 1, publish subnet, and then come here and see route table, right? And then the route table has right now, it has this route to the internet gateway, okay? How about the private? It has a local one here. All right. So just by doing that, and I think that AWS improved this a lot, because before you have to associate the route table with the internet gateway. But right now, you see, you have the internet gateway here. It's associated with that. Okay. This is the internet gateway that is attached to that. It seems that now it recognizes this word here and it just attaches the internet gateway, because I just created these 4 subnets here, right? The same way I did with all of them, okay? And the private ones, they don't have anything associated here. If you take a look at the other private one, there's no association here. But if you take a look at the public ones, the internet gateway is associated, and the internet gateway is not associated with this one. which I have to edit this guy here. Okay. So it seems that the first one that I created, the first one that was created, that one that I changed the name for later, it just created that association letter. Okay. Okay. We will have to complain to AWS probably because this is having issues here. It doesn't let me see. Look at this. Oh my God.
Maybe it's just a browser issue.
Yeah, probably. I don't know. This is something new, very new. Okay. Okay. So this is the route table. Okay. So I can create a custom route table here. This one has some routes here that you can change. So this one is associated with my first VPC, right? And it will work with that subnet here. Okay. Subnet associations here. See? Let me take a look at the this one here and see there's here association here. I can edit this, and then this guy associated subnet with the main route table, and then I can change that. Okay, I'm not gonna go into that now, but what you have to understand is that when a subnet is associated with an internet gateway, that makes it a public subnet. If it is not associated, then it doesn't. It is not a public subnet. It's private. Okay. So reserved IP addresses, we have this IPv4 CIDR block of 10.0.00/16 that has the amount that we've mentioned several times, 65,536 total IP addresses. And this VPC has 4 equal size subnets. Only 251 IP addresses are available for use by each subnet because Amazon AWS will take 5 IP addresses. If I go here to subnets and I see this is the 4 that I created, you see 251 because Amazon will take 5 per subnet. Okay, 5 per subnet. So we have here subnet 1. Subnet 1. This is exactly what I did, guys. If you take a look at my architecture, and this one is the same. 16, notation 16, 24, 24, 24, 0, 1, 2, and 3. 255 to 51 addresses. This is exactly what I have in my console right now. Okay, so Amazon will take 5. The first one is the network address. Okay, and the last one is the broadcast address. So that's standard. The first one and the 5th is standard for every network. The other ones are Amazon. Internal communication, right? That's for the router. Domain for the DNS resolution and for future use. Okay, so that's standard. That's automatic. When you create a subnet, it subtracts 5 from that number, from the number of IP addresses. Okay. IPv4 IP addresses types. You have v4 and elastic IP. We spoke about elastic IP on Wednesday. We said that that's an IP that will always remain there. Okay. When you stop an EC2 instance, automatically when you start it, you're gonna be assigned a new one. That always happens. The only way that you can keep the same IP address is by attaching or associating an elastic IP. That's the only way. Okay. But it will cost you. The first one is free. The first one is free as long as it is attached or associated to a running instance. If the instance is not running and you're not associate your IP address, elastic IP address with any EC2 instance, then you're going to be charged for that. Okay. So manually assigned through elastic IP address, right? And automatically assigned through the auto assigned public IP address settings at the subnet level. Okay. So
Don't they associate a domain with your EC2 instance?
if you have a web server, yes. You also have a DNS. Whenever you create an EC2 instance, you have a DNS, which is an URL. Okay. So that's the address that you can use to access that EC2 instance through the browser. So when you create an EC2 instance, let me create an EC2 instance real quick here. Let me just go move forward and launch. I'm gonna launch now, right? No key this time, no key. I do this and then I make this smaller. Okay, so now if I take a look at the instance, this is gonna be the URL that I'm providing. This is the website for that instance. Right? So either you can use this DNS or you can use this IP address, whatever you want to use. Okay. Of course, if this is not a web server, you will not see anything. Okay. It just will do nothing, right? Because there's nothing to print, there's nothing to display. But if you have some servers with some HTML code or something, then this is the guide that you can paste in the browser and then you can see it. If I open this, okay, this is not even working. Oh, but what is running already? It's running already. I don't know why this is not even clicking. But I can copy and just paste it here, the browser, and you will not see anything. There's nothing to see, right? It will hang there for a while and then time out, right? First, because there's nothing to print. Second, because port 80 is not open, okay? But even if I, port 80, I open it, there's nothing. There's nothing to print, okay? But that's basically the website to see whatever you have there. Of course, you can buy your domain and just redirect it to your domain. That's possible, okay? An elastic IP address is associated with an AWS account. It can be allocated and remapped anytime. It's only one IP address per EC2 instance. You cannot associate the same IP address with another EC2 instance. Okay, it's only one. You will have to disassociate it and then associate it again with another one. Okay, so when it says you remapped anytime, it means disassociate from one EC2 instance and associate it to another one. Okay, additional cost might apply. Okay, if it says might apply because the first one, as long as it is attached to one EC2 instance that is running, it's free. But other than that, you're going to pay for that. So an elastic network interface, is a virtual network interface that you can attach to an instance, right? Detach from the instance and attach to another instance to redirect traffic, network traffic. This is it's very commonly used with EFS, elastic file system, that you mount on the network. It's a network file system that you mount on the network, and where you mount it is in a virtual network interface, okay? And of course, that interface is gonna be attached to an instance, okay? So it's its attributes follow when it's reattached to a new instance. Okay, so every attribute that it has, it would be also attached to that instance when you attach to the network interface. Each instance in your VPC has a default network interface that is assigned a private IPv4 address from the IPv4 address range of your VPC. Okay, so you have here a subnet that's 10.0.1.24, and then the network interface is going to be here, and then it's going to be assigned an IPv4 address from this range that you have, the one that we put in the VPC, 10.0.0.0/16. It's going to grab one IP address of those 65,536 IP addresses and assign it to the elastic network interface. Okay. The route table and routes. Okay, a route table contains a set of rules or routes that you can configure to redirect or direct the network traffic from your subnet. Every subnet has a route table. It has a route table, or it should have a route table. There's a default route table that comes with your account when you create the account. The account creates, when you create the account, a VPC is created, a default VPC. 6 subnets are created. A default route table is created. A default internet gateway is created. So their default value, right? It contains a local entry. It means that it allows traffic inside that subnet between resources inside the subnet. That's why it's a local entry. Okay, and of course the destination is the VPC block CIDR. Okay, that's the CIDR of the VPC. So by default, each route specifies a destination and a target. Okay, the target is local and the destination is this one. By default, every route table contains local route for communication within the VPC. So every single subnet has a route table, and every route table has a local entry, all of them, to allow communication within that VPC, right? So each subnet must be associated with a route table, at most one. Only one per subnet. So only one route table per subnet. And it says must. So it's not optional. It's must. Because there has to be traffic inside that subnet. And the route table is the one that has that definition and the destination and the target. Okay. You can add entries. Okay. You can customize, you can have your own customized route table and add entries as you wish. Okay. Coming from different places inside that VPC. So takeaway of this section, the VPC is a logically isolated section of the AWS cloud. A VPC belongs to one region and requires a CIDR block. It belongs to one region, but you can have several VPCs in one region. But you will not have a VPC in another region that is the same as this one. You can have another VPC, but it's not this one. Okay. A VPC is subdivided into subnets. That's a good way to fragment your network and make it more organized. And a subnet belongs to one AZ and requires a CIDR block. The VPC requires a CIDR block too, and so does the subnet. Okay, so remember, VPC spans across multiple availability zones. A subnet only in one availability zone. Okay, and they cannot overlap. Don't forget that. Route tables control traffic for subnets. That's why we have to have, there's not a choice, we must have a route table per subnet. Okay, route tables have a built-in local route. That's the local route that has a destination and a target. Okay, you add additional routes to the table. The local route cannot be deleted. You can delete your entries, the other entries, but not the local one. There has to be traffic and communication inside the VPC. There has to be. It's not a choice. It's a must. That's why you cannot delete the entry, the entry route, the entry route. VPC networking, we have a network gateway. Internet gateway is the one that makes the magic of connecting that subnet or that VPC to that guy to the internet. Okay, so when you have a public subnet like this one, you're gonna have this local entry, but then you're gonna have this guy. Okay, so your route table is going to have this entry right here. And this is pointed to the internet gateway. That's the target. And the internet is the 0.0.0.0/0. That's the internet. It means that every single IP address in the world can come in to the VPC through port 80, which is the browser, or port 443 if it is HTTPS. Okay, that's very important. That's what makes a subnet public. This little entry here. Okay, so we have a region here that's above the VPC, and of course the cloud, AWS cloud, is above everything else. Okay, we have inside the region an availability zone, and then inside the availability zone we have a VPC, right? Actually, it's not inside; it's inside the region. The availability zone is inside the VPC. Not the VPC inside the availability zone. And then here we have the subnet, right? And we have the CIDR here for the VPC, which is, the /16. It allows how many addresses, guys? How many addresses? How many addresses does this
1,000.
notation? How much? How many?
65,000.
How much? How many?
65,000.
65,000.
Yeah, I don't know.
You're missing a lot. Oh, Maro, you're missing a lot. 65,536. Okay. And then we have this public subnet that is the 10.0.1.0/24. And then this one, which is private, right? And then we have 10.0.2.0/24. This one has an entry in the public subnet that is what? To internet gateway. This one doesn't have that entry. Okay. What do we have here? This is what? The route table, right? We have a route table per this, right? Now we have an internet gateway here, right? This is a public subnet. That's why it has connection to the internet gateway, right? And then we have connection to the internet, right? Whenever you see IGW-ID, that's the ID of, that's a short for ID for the internet gateway. Okay. Now we have the NAT gateway. The NAT gateway is what allows the private subnet to connect to the internet. Okay. That's why we have this local entry here. Local entry, and then we have this NAT gateway entry here. So in the public subnet, we have this internet gateway entry. In the private subnet, we have this NAT gateway entry. Okay, and the destination is going to be the internet. Okay, so we have this private subnet, right? And then we have this NAT gateway here. This is the ID, NAT gateway. All right. So the NAT gateway will let this guy here to connect to the internet. Okay. So it moves here, right? And then it will move from here to here, just in case you want to, download something from the internet. And it will also come from here to here, and then here, just in case someone wants to communicate through the internet. Okay.
Quick question.
Go ahead.
So the NAT gateway acts as a proxy?
It's like a proxy.
Okay.
Yeah. Okay. So it would be there to allow these guys to connect to the internet. Okay. So that's the main function of the NAT gateway. Okay. There's something else called NAT instance, which is an EC2 instance, a special EC2 instance that you can, whenever you go here and you create an EC2 instance, you can come here. If I just, okay, here, right? And I type here NAT. AWS keeps changing this. Okay. This is where I used to get the NAT instances from this section here. Now I find it, the very first line here was a NAT instance. Now they keep changing this. Let me let me do this. Open this EC2 console. And then EC2 in the navigation pane, choose instances, select the NAT instance, choose actions, network, choose instant in the navigation pane. Okay. Okay, one moment. Instances. Okay. In the navigation page, choose instances, select the NAT instance. Choose actions, then working change. Okay, that's not what I want. They keep changing this. Before, you can come to the marketplace and get an instance there for free. Well, not for free, you have to pay for it, but you know, it's okay. Using the main, okay. NAT instances. Okay. So launching a NAT instance using the command line, that's not what I want. Setting up the NAT instance, you can use the VPC wizard to set up a VPC with the NAT instance. Create a VPC, launch an instance into a public subnet, optional. Launching an instance using the command line. Okay. I have to do some research here, guys, because AWS keep changing things. Okay. Okay. I guess that I have to be more informed about this NAT instance. All right, so that's not the scope. You don't need to create a NAT instance. Actually, you don't create it. You don't need to find it for your exam. It's just something that I want to do extra, you know? Okay. So NAT instance is also another option, but a NAT instance is less highly available than a NAT gateway. A NAT gateway is super highly available. If a NAT instance goes down, you lose everything. Okay, that's why it's not that good compared to a NAT gateway. A NAT instance is a simple EC2 instance that acts as a NAT, right? NAT gateway is super highly available. It doesn't fall. It doesn't, you know, crash or anything. It's not a server. It's a service. Okay, and it's super highly available. It's a device in the network, like that the internet gateway. It's a device in the network. Okay. So VPC sharing, you know, you have a region VPC account 8 owner, right? And then you have a VPC private subnet here, account B participant, account C participant. So you have two accounts here. And then you have a router that connects with the subnet, public subnet, account D participant. And then you have a NAT gateway there to connect with the private subnets, and then you have an EC2 instance and the Amazon Redshift. Okay, so this is one of those instances when you put an Amazon Redshift, like something that has to do with data in a public subnet, not very common, okay? But this is one of those cases, okay? Amazon Redshift is super, super, super secure, okay? But you know, it's I wouldn't recommend putting something with data in the public subnet, okay? What you always put in the public subnet is the NAT gateway. That has to be in the public subnet, okay? Of course, it has to be, you know, associated with the NAT gateway, okay? As you can see here in the private subnet, you see the Amazon RDS. So usually best practice is to put whatever has to do with data in a private subnet, because you don't want anyone from the internet accessing this guy, okay? That's why you have the NAT gateway here, okay? So VPC peering, that's what I spoke about, you know, a while ago. Region VPC account owner. So you can do some peering here, right? You can have some VPCA. You have this 10.0.00/16, and then you have this another one here, VPCV 10.3.0.0/16, and then you can have a connection there. Okay, it's a VPC peering connection, right? Now, very important. If you want to connect a third VPC, very important, and you make a connection between VPC-C and VPC-V, you know, like a peering connection between those two, it doesn't mean that VPC-C is going to be connected to VPC-A. Very important. This doesn't have a way to connect this VPC here, the C1, which you don't see, but let's just imagine there is a VPC-C here, right? And I just established a peering connection between C and B. Okay, that doesn't mean that C is connected to B. So you will have to create a VPC peering between VPC-A and VPC-C, okay, to be able to connect, okay? This doesn't transfer to this, okay? If we have this, it doesn't transfer to this. So you have to establish an individual VPC connection between two VPCs for them to connect, okay? So as you can see here, the route table for VPC-A, it has a local one, you know, for their to be communication inside, right? And there has to be a route entry here that points to that VPC peering connection, which is this ID here. The same happens this here, okay? So this guy is going to point to this, right? And this guy's gonna point to this, and that's where you make the connection here, right? And then when you make the connection, all the resources in this guy here, they can communicate with this guy here, okay? So very important. And by the way, the limit for a new account, the one that you have now is 5 VPCs per account, okay? Per region, okay? Per account. So you can connect VPCs in your own AWS account between AWS accounts or between AWS regions. So restrictions, IP spaces cannot overlap. Transitive peering is not supported. That's what it was talking about. That doesn't transfer to the other one. There's no transitive peering, okay? You can only have one peering resource between the same two VPCs, okay? It's only one peering connect resource. You're gonna have two VPCs, two VPC resource, peering resource, okay? So you can search for AWS limits for new accounts. Okay. And then you see, I can scroll down now with my mouse, but I cannot click. So that's weird. Okay, now I can click, and I click on the wrong place. Okay, so Service quotas. Let me see if I can see here. Let me see here. No, I don't see anything here. Okay, I can see. Maybe here. No. All right. So how many VPCs per AWS account? 5. Right? So you can have up to 5 non-default VPCs per AWS account per AWS region. Right? So you say per account. Right? You can have up to 4 secondary IP ranges per VPC. And you can create up to 200 subnets per Amazon VPC. You can have up to 5 Amazon VPC elastic IP addresses per AWS account per AWS region. Okay. So guys, I recommend, understanding this because limits can surprise you in the exam. Okay. So let me put this in our account here. Okay. So we continue. Side-to-side VPN, for this you need to have internet. So this connection requires the internet. It requires a virtual gateway that has to be on the AWS site, and it requires a customer gateway on the corporate and the on-premises side. Okay, as you can see here. So the internet's gonna be there. You need internet, and this is what we call a side-to-side VPN connection. Okay, so you can establish a connection between the on-premises and the cloud through the internet, which is not secure. Whenever there's internet, there might be some problems with security. The man in the middle, things like that, right? So what is more recommended is direct connect. Direct connect doesn't need the internet. Okay, as you can see, the internet is outside. You don't need it. It's just fiber optic private links that AWS has, and this is dedicated for you only. And this is more expensive than side-to-side VPN connection. Okay.
Oh.
So we have this availability zone here. We have the subnet, the public and the private. We have the route table. The same thing inside the AWS cloud, but now we have a virtual gateway, right? Which is gonna be here at the door, at the door of the VPC. And then we have the internet connection here. That's the point of contact here, the point of connection, right? Between the virtual gateway and the customer gateway, right? It makes sense, right? So
Who provides this side-to-side VPN, the internet providers?
No, you can do this in AWS, but you need the internet. You need the internet for that. Okay, you will use the internet for that. This is just a graphic, right? You need the internet for that. It's a connection that you establish, between the two of them that you can create in the console, right?
That means that I'm using the internet.
And then you have to use the internet because that requires the internet. Like your browser requires the internet to find a website, same thing.
Right, but like I'm a corporate, I have this building here, and I want a side-to-side VPN connection from my office here, and I'm paying, right, for my internet through Verizon or some kind of provider. So I'm paying for this.
I thought that you were asking me if the internet provider provides that particular side-to-side VPN connection. No, you need the internet. Of course, you have to have an internet provider like AT&T or Comcast.
Yeah.
But you need the internet for this connection. The internet is crucial for this connection, right?
Yeah.
That makes it more insecure than the other one. Okay. So you need this, you have to create this in the cloud. You have to have this in the premises, right? And then you create this connection. As you can see here, the public subnet, right, has this entry, and then it has this particular internet gateway, right? And you will see this particular, the private subnet that is right here. It has this guy here. That is the address that we are targeting here. It's a destination here, right? That's the address in the corporate center. Okay? That's the entry that this guy here that's pointing to the virtual gateway. Okay, so this guy here, you know, it's the publisher net, right? So you're having like you're having the entry to the internet gateway, like we did before. Of course, they don't show you the internet gateway here because this is a site VPN, so it's coming from this private subnet here, right? AWS Direct Connect, it's more expensive, but it's more secure. Okay, and it's super highly recommended. It's super fast as well, right? Super fast. Sorry. We have the same thing here, right? This is established by AWS, right? We don't need internet here. AWS has established this. There's a point of contact there. Here, it's a center, right? Center for connection. And all this connection here is through fiber optic, right? Fiber optic, everything. And that costs money. Okay. So we're gonna have this virtual gateway, this VLAN, virtual LAN, virtual local area network. And then we have this guy here in customer gateway. And then we have this, again, this IP address here. Now, guys, how many IP addresses can we have here with this 24/24? Do you remember?
$500, more or less.
No, you don't say more or less. There's no more or less here. It is one value.
Or what value?
250 and 56. Don't forget that.
100,
256.
200.
Yes.
Yeah, 20 is 496, right?
Yeah, 23 is 512. 22 is 1,024. 22 is 2,048. And 21 is 2,048. And 20 is going to be double that. 5,096, right? Something like that. 5,000, yes, 96. Right, but this is 256, right? So VPC endpoints, okay? VPC endpoints is for your resources inside your VPC to connect with resources that don't depend on a VPC. We have resources that are not VPC based, and one of them is S3, okay? S3 doesn't need to be in a VPC. Lambda doesn't need to be in a VPC. DynamoDB doesn't need to be in a VPC. So those guys don't need a VPC. But EC2 instance, it has to be in a VPC, right? So we have here an elastic network interface, also ENI, and then you create a VPC endpoint here. This is the VPC endpoint, and this is the ID. And then what we're gonna do is just come here and extract whatever information we have here in the S3 bucket. Okay. So these are the default DNS hostname or endpoint specific DNS hostname. Those are the guys that are gonna be using this elastic network interface, those guys, to communicate with this service here through the endpoint. Okay. That's why you see in this public subnet an entry to that VPC. Okay, endpoint. Right. So basically, what you guys need to know, and Amazon AWS has made this more complicated than before. for this for the exam. This was not in their curriculum. They didn't have this before. They have made this more advanced. Even I have seen this even in the solutions architect preparation for the exam. So this is even more complicated. But you have to understand that VPC endpoint is to connect whatever services you have inside the VPC with services that are not VPC based. That's the main point. All right. So there are two types of endpoints: interface endpoints powered by AWS Private Link, and gateway endpoints, Amazon S3 and Amazon DynamoDB. Okay. So those are the two endpoints: interface and gateway. All right. Guys, it's right now. Do you have any questions? Any questions? No? No? Yes? Maybe? Okay. So if you don't have any other questions, I think it's time for the break. It's 6:53. Let's meet back here at 7:03. Okay? 10 minutes break. Okay, guys, are we back?
Yes, I'm back.
Okay, good. So in this section here, you can see AWS Transit Gateway. So you can configure your VPC in several ways and take advantage of numerous connectivities, options, and gateways. So these options and gateways include AWS Direct Connect, AWS gateways, NAT gateways, Internet gateways, VPC peering, etc. And it's not uncommon to find AWS customers with hundreds of VPCs distributed across AWS accounts and regions to serve multiple lines of business, teams, projects, and so forth. So things get more complex when customers start to set up connectivity between their VPCs. All the connectivity options are strictly point-to-point, so the number of VPC to VPC connections can grow quickly. As you grow the number of workloads that run on AWS, you must be able to scale your networks across multiple accounts and VPCs to keep up with the growth. So through you can do this, and though you can use VPC peering to connect pairs of VPCs, managing point-to-point connectivity across many VPCs without the ability to centrally manage the connectivity policies can be optionally costly and difficult. For on-premises connectivity, you must attach a VPN to each individual VPC. So this solution can be time-consuming to build and difficult to manage when the number of VPCs grows in the hundreds. So to solve this problem, AWS created a transit gateway. So before we have this, right, this bunch of things here, customer gateway to VPC, VPN connection, another VPN connection, another VPN connection, then Amazon VPC, then another VPC peering with another VPC, then another VPC peering, and all that. You see, that's crazy. Okay, that's great. This Amazon VPC with connect gateway with this Amazon VPC, this is absolutely crazy. Now they get this now, this transit gateway, and they can connect one thing to the other. So this VPC can be connected to this VPC through the AWS transit gateway, and this VPC, and then this direct connect gateway can be connected to this, and this VPN connected. See, so instead of having all these bunch of services, a bunch of devices in the network and things like that, so they come up with this idea, and now things become very easy. Okay, so you only need to create and manage a single connection from the central gateway into each VPC, right? On-premises data center or remote office across your network. So a transit gateway acts as a hub that controls how traffic is routed among all the connected networks, which act like spokes. So this hub and spoke model significantly simplifies management and reduces operational costs because each network only needs to connect to the transit gateway and not to every other network. So any new VPC is connected to the transit gateway and is then automatically available to every other network that is connected to the transit gateway. This ease of connectivity makes it easier to scale your network as you grow. Okay, this one, when you grow, you have to create another connection. But simply this, you just create a new VPC and connect to the transit gateway. That's it. So this is the single point of connectivity. All right, pretty good, huh? It's much better than this. So they continue renovating their services and creating more stuff, so the customer's life can be much easier. Okay, so guys, let's do this. Can you please identify the services here and the things that are here in this architecture? Can you do that?
The blue flag is a region.
This one is a region. How about this one?
That is a availability group.
Group?
Availability zone. What am I saying? I
Zone.
think it's SQL Server.
So how about this one?
That's a VPC.
Good. How about this one?
EC2.
EC2? No.
Public subnet.
Public subnet.
Oh,
Subnet.
public
Subnet,
Okay. How about this one?
not gateway.
Gateway.
Gateway. Nah.
The NAT gateway. How about this one?
EC2.
IP address, private.
Oh, you're right. EC2.
Elastic IP. Elastic IP.
But
Elastic
elastic IP, yeah.
Okay. How about this one?
Public. I mean, private.
Private subnet.
How about this one?
What was that thing?
Could be IP, static IP.
No.
Oh, this is a network card.
Okay. Similar. Elastic network interface.
Elastic.
Okay. How about this one? Oh,
Route table.
oh. And this
Route
one?
table.
Internet.
Internet, yeah.
Internet what?
Gateway or
Gateway. Internet gateway. That's right. How about this one? It's the entire thing. What is that?
route.
Route what?
Route table.
Route table. How about this one?
Route.
So what is
Route.
okay? What is this?
IP.
VPC IP address.
Yes, that's the CIDR of the VPC, which is here. Which one is it? It's right here. You see here?
Yep. Yep.
It's right here. And what is this here? What do we have here?
Gateway.
The what?
Internet gateway.
The
Okay.
internet gateway.
Okay. So take a look at that and see if that is similar to what you told me. Okay. So now we have here okay. One moment. Okay, I have a small demonstration here that I can show with you guys. So it's just a small one. No, not that one.
Hey, it's Alan.
This one.
Hey, this is Andrew Brown from Exam Pro, and we are looking at virtual private cloud, known as VPC. And this service allows you to provision logically isolated sections of your AWS cloud where you can launch AWS resources in a virtual network that you define.
This is the one that I have.
I'm hearing a lot about how Amazon Virtual Private Cloud, Amazon VPC, enables you to build a secure
I'm hearing a
virtual
lot about
network
how
in the
Amazon
AWS
Virtual
Private Cloud, Amazon VPC, enables you to build a secure virtual network in the AWS cloud. Can you tell me more about it?
Yes, you can easily create your own virtual private cloud. No hardware or physical data centers required. You can define your own network space and control how your network and the Amazon EC2 resources inside your network are exposed to the internet.
What sort of security options do I have over my virtual network?
You can leverage the security options in Amazon VPC to provide more granular access both to and from the Amazon EC2 instances in your virtual network. For example, you can create a public-facing subnet for your web servers that have access to the internet, and place your backend systems such as databases or application servers in a private-facing subnet with no internet access.
What if I don't want to connect my secure network to the internet and want to restrict access to it only from within our corporate infrastructure?
You can easily create a hardware virtual private network, VPN connection, between your corporate data center and your Amazon VPC, and then leverage the AWS cloud as an extension of your corporate data center.
Interesting. Can you tell me more about the security features?
Advanced features such as security groups and network access control lists can be used to enable inbound and outbound filtering at the instance level and subnet level. In addition, you can store data in Amazon S3 and restrict access so that it's only accessible from instances in your VPC. You can also choose to launch dedicated instances, which run on hardware dedicated to a single customer for additional isolation.
How do I control the flow of data?
VPC route tables give you the ability to control how your traffic is routed within your VPC, between subnets and to or from the internet or your corporate data center.
Can you tell me a little more?
It is actually very simple to get started. You can create a VPC quickly and easily using the AWS Management Console. You can select one of the common network setups that best match your needs using the VPC wizard. Subnets, IP ranges, route tables, and security groups are automatically created for you, so you can concentrate on creating the applications to run in your VPC.
What if my requirements change? How quickly can I modify my AWS resources?
Amazon resources in a VPC can be modified and scaled up or down. Anybody using AWS can use Amazon VPC, from individuals hosting a single web server to large organizations that require thousands of machines. In fact, when you launch new Amazon EC2 instances, by default, they will be launched into a VPC. You also have the option of launching instances outside of VPC if required.
And what kind of solutions are people building inside VPCs?
Amazon EC2 is being used inside VPCs for purposes such as hosting basic web applications, like blogs or simple websites, where you can gain the additional layers of privacy and security afforded by Amazon VPC. You can help secure a website by creating security group rules, which allow the web server to respond to inbound HTTP and SSL requests from the internet, while simultaneously prohibiting the web server from initiating outbound connections. You can also host multi-tiered web applications inside a VPC to strictly enforce access and security restrictions between your web servers, application servers, and databases. You can launch web servers in a publicly accessible subnet and application servers and databases in non-publicly accessible subnets. The application servers and databases can't be directly accessed from the internet, but they can still access the internet via a NAT instance for tasks such as downloading patches. You can control access between the servers and subnets using inbound and outbound packet filtering, provided by network access control lists and security groups. VPC route tables give you the ability to control how your traffic is routed within your VPC, between subnets and to or from the internet or your corporate data center.
Does everything need to be in the Amazon data centers? We have databases within our corporate network that we would like to keep on premises.
You can keep whatever you wish on premises. You can easily create a VPC where instances in one subnet, such as web servers, communicate with the internet, while instances in another subnet, such as application servers, communicate with databases on your corporate network. An IPsec VPN connection between your VPC and your corporate network helps secure all communication between the application servers in the cloud and databases in your data center. One nice thing about Amazon VPC is the console wizard provides you with 4 templates that can be used as a starting point. You can easily extend and customize your VPC to meet your requirements.
How do I access and manage my Amazon VPC?
There are a number of options. The Amazon VPC console, the AWS command line interface, Amazon EC2 command line interface tools, and AWS tools for Windows PowerShell.
How much does it cost?
There is no additional charge for using Amazon Virtual Private Cloud, aside from the normal Amazon EC2 usage charges. As usual, you only pay for what you use as you use it. There are no minimum fees and no upfront commitments.
Awesome. I think I'm ready to get started.
AWS provides free online training with a self-paced lab to get you started without having to open an account.
That's cool. How do I take the free training?
Before you get started, let me show you how easy it is to use the Amazon.
Okay, guys, you can watch the rest of that, but at least you have an idea how much you can accomplish with a VPC. Okay, so let me put this on Slack, so guys, you can have access to that if you want to watch the video, you know. Okay, right here. If you want to watch that, it's okay. So there's several VPC networking options, which include Internet Gateway, NAC Gateway, VPC standpoint, VPC peering, VPC sharing, AWS site-to-site VPN, AWS Direct Connect, AWS Transit Gateway. You can use the VPC wizard to implement your design. The VPC wizard is what I show you guys here. This is the VPC wizard. You're coming here to VPC. And then this is the VPC wizard, okay? You can do whatever you want here. You can have all the NAC gateway here, the subnets here, the route table, internet gateway, egress only internet gateway. This is only for IPv6, okay? DHCP option sets, elastic IPs, endpoints, endpoint services, running instances, site-to-site VPN connections, virtual private gateway, customer gateway. So you have so many things here that you can do when you do that. You can even launch a VPS EC2 instance from here. All right. And I can tell you this, Amazon has improved this a lot. As you can see here, then always a new here, new. They're improving this all the time, every time, you know. Private, virtual private gateways, customer gateways, create this, creating this from the AWS in connection with the on-premises location. That's amazing what they have created here. So many things, so much to learn from them. Okay. So VPC security, we have here some security groups here. Okay, this is a security group that you can use in an instance, right? So instances use security group, whether an instance for an EC2 or an instance for a database. So they use that. Also, they act at the instance level, something that you have to remember. They don't act at the private at the subnet level. At the subnet level, we're gonna have something else that's gonna be the NACLs, okay? Or network access control list. So very important, security groups are stateful. Okay, they're stateful. Just remember that, the word stateful. It means that when whatever comes in, goes out, okay? If you bring something, or you access your account, my account, and the security group lets you in, you can go out easily. So let's imagine that I enter your house, right? I enter your house. I show you my ID. First, I knock on the door. You open the door, I show you my ID, you let me in, I do whatever I want to do in your house, and you want to go out, I don't have to show you my ID again. Okay? So you know who I am, right? So if I come in, I come out. Okay? If I go in, I come out. So that's stateful. You keep the track of the state, of my state, right? I am a person that enters, my name, my ID, everything. I enter and then I go out. You keep track of me while I'm inside the house. So you know who I am. I'm sorry. You know who I am. That's why it's called stateful. So security groups, they have an inbound rule and outbound rule. Okay. So they can have a type. It can be HTTP, SSH, Another one, HTTPS, different RDP, different types. They have a protocol, right? And they have a port range. They have a source. In this case, is coming from another security group, and they have the description. Okay. Outbound rule is going to be all traffic. Okay. It means that whatever comes in goes out. Okay. Security groups have rules that control inbound and outbound rules. Outbound instant traffic. Default security group deny all inbound traffic and allow all outbound traffic. Security groups are stateful. All right. By default, all the traffic is denied. Okay, by default. So you have to allow it. And how do you allow traffic? Opening ports. Okay, that's with the security group. Okay, custom security groups, you can have some custom. This is the default one. You can have some custom. That's what I've done so far, guys. HTTP, you're opening. Sorry, my God, this is crazy. HTTP, you're opening port 80, right? The source is any IP address and all web traffic. HTTPS, you're doing the same. The pro is TCP, 443, and that's going to be any traffic. Okay. SSH, TCP, that's the protocol transport, and the 2022 port, and the only address that's going to be able to SSH into my account is this IP address, 24.54.24.12.19. That's the only IP address that can access my account via port 22. The only one. Okay. Remember we said that /32 is only one, right? So if they ask you in the exam, what does this mean? That you have this 54.24.12.19/32. It means that only IP address can access the account via port 22, and this is the address. Okay, and this is, whatever comes in will go out. Okay, so you can specify the allow rules, but not the deny rules. Okay, because by default is deny, right? All rules are evaluated before the decision to allow traffic. So deny is evaluated before allow. Just remember that. Okay. Now, the other guy that we have is the NACLs. Okay, NACLs, Network Access Control Lists. They act at the subnet level. So security group act at this instance level, as you can see in the screen. NACLs act at the subnet level. So that's another extra layer of security. Okay, so this will protect the subnet, and in turn, they protect the whatever is inside the subnet. Security groups, they protect the instances. Okay, now subnets are stateless. It means that they don't keep track of the state. Okay, if I enter your house and I show my ID, right? Just knock on the door, show my ID, you let me enter the house, you let me in, and then when I come out, you require that I show you my ID again, because you don't know who am I, right? When I enter, I show you my ID, you know who I am. But when I come out, you just forgot. You don't keep the state of me. You don't keep that ID, that name with you. So you don't keep the state, right? That's why it's called stateless. Okay. Now these guys, as they are stateless, you have to have inbound rules and outbound rules. You have to have that. Okay. So rules are evaluated by increments on 100. Why do you do that? That's not mandatory, but it's recommended, because in the middle of the way, you may want to add another inbound rule that's going to be in the level of the 100s, and then you can put it in between, right? Otherwise, if you have 100 and then you put 200, just like that, it's going to be a little more confusing. So, if you put 101, for example, then if you want to put something before the 101, you cannot, because you already have a 100, okay? Unless you delete that one, right? So it's better to put 100, 200, 300, 400 increments of 100 to leave space for changes, okay? And forget, allow has less precedence than deny. Deny is more important than allow, okay? If there's a deny of one IP address, and there's an allow of the same IP address, forget about is deny. Okay, forget about. Deny has more priority than allow. Okay, you see here, there's a 100 here, and then it allows store traffic. It has all these sources allow, and then it has a deny here. So it's gonna read from this, and then when it gets here, it's gonna deny. Okay, it doesn't read deny first, right? It just read from top to down, and then it will deny later. A network ACL has separate inbound and outbound rules, and each rule can either allow or deny traffic. Default network ACLs allow all inbound and outbound IPv4 traffic. Networks ACLs are stateless. Don't forget that they're stateless. Okay. Now we have a custom network ACL. You can have that. This is the default one. This is the one that you can, you guys can create as a customized one, right? So custom network ACLs deny all inbound, outbound traffic until you add rules. So by default, they deny everything, right? You can specify, you see, you can specify, okay. So this one, the default one allows by default. The custom, denies all inbound and outbound rules until you add rules. All right, you see the difference? The default allows by default, the custom denies by default until you add rules. So you can specify both allow and deny rules. Rules are evaluated in order number. In order number, starting with the lowest number. So it comes from this way, 100, you see, and then 103 for the lowest number. Very important. So it doesn't matter if you put it after or before, the lowest number will be first, and then the other one. All right, super important. Okay, right now we have here security group versus network ACLs. This is a good comparison table, guys, that you can take a look at later. We're gonna see now, but later you can sit and try to understand it better. Scope, security groups, we said that they work at the instance level, and the network ACLs, they work at the subnet level. Okay, supported rules, the security groups allow rules only. Okay, allow rules and denies. You don't do a deny with a security group, you only allow. Okay, and with network ACLs or NACLs, you can allow or deny. The state, remember that security groups are stateful. Return traffic is automatically allowed regardless of rules. So whatever comes in goes out. Okay, network ACLs or NACLs, they stateless. So the return traffic must be explicitly allowed by rules. Okay, so you have to work on the inbound rules and you have to work on the outbound rules. Not necessarily are the same. In the case of the security groups, they are the same. Whatever comes in goes out. Order rules, all rules are evaluated before decision to allow traffic. Okay, in the case of NACLs, is by the order of number. Okay, the smallest one would be the first one to be evaluated. Okay, very important. Now, activity. Guys, we don't have time for this. Unfortunately, we don't have time for this. Okay, so this is something that you can, guys, I wish we had time for this. We don't have time for this. There's so much content for 3 hours because this class should have more time. Okay, so you have a small business with a website that is hosted on an Amazon Elastic Compute Cloud, Amazon EC2. You have customer data that is stored on the backend database that you want to keep private. Okay, you want to use Amazon VPC to set up a VPC that meets the following requirements. Your web server and database server must be in separate subnets, right? Let us not build this, but let us think about it. Where will you put the web server? Where? Where? In what subnet? In the public subnet. In the public subnet. That's the web. It means that it will have access to the internet, right? And the database will be where?
Private.
Private subnet.
Right. The first address of your network.
Depend.
Yeah.
It's a redshift.
Yeah, but the Redshift, I mean, they give an example, but whatever you have
Okay,
data,
okay, I got
when
it.
you have data, you know, it's better to put it in the private subnet.
Okay,
The first address of your network must be 10.10.0.00. Each subnet must have 256 total IPv4 addresses. Okay, so in that case, we have to do what notation? Slash what? Slash what?
28,
24.
24. Okay.
Okay, 24 is 256. That actually is 251 because Amazon takes 5. Don't forget that. Your database server must be able to access the internet to make patch update. What do I need? Database is in the private subnet. What do I need to have in place for that database to make patch updates?
That proxy, that NAT,
NACL.
NAT.
No, it's not the proxy. It's the NAT.
NACL.
What? NAT gateway.
Get NAT really.
NAT gateway. I need a NAT
Yeah,
gateway
yeah,
for
NAT
the
gateway.
private for
NACL
the
is
resources
secure.
in the private subnet to access the internet. I need a NAT gateway. Okay. Remember, they don't have any entry that points to the internet gateway. They have the NAT gateway, but not the internet gateway. The one that has access to the internet gateway to the internet is the public subnet. This is in the private subnet. Your architecture must be highly available and use at least one custom firewall layer. Okay, at least one. You know, we need to have security groups or these guys, the NACLs. Okay, and highly available, we have to have at least 2 availability zones to make it highly available. One availability zone is not highly available because if the entire availability zone goes down, you're screwed. So you have to have 2. Okay, so you have to have 2. So build security into VPC
No,
architecture.
cool question. So when you say you have to have 2, you're
No,
creating.
You don't have to. You should have.
Okay, so you have your web server and your database on the availability zone that is like 1. Do you
One
how
primary, one secondary to make it highly available. So you're gonna have 2 web servers, 2 web
okay,
servers, right?
I
2
see,
web
I see.
servers and 2 databases.
Got it.
You're gonna
Okay,
have a
now
master. You're gonna have a master database and a standby one.
got it. I got
Right?
you. Yeah,
So
yeah.
this, if the first one goes down, it fails over to the other one.
But I thought that it was so smart, Amazon, that
No,
I
this
could
is-
build it. I could build it in just one availability zone, and they automatically would put me on the other one. But I guess that's not the case. So
No. This is not automatic. You have to
Yeah.
configure it. You have to configure it. There's some services that have high availability built in. They're natively highly available.
more at
But-
the
but
platform
not
as a
into-
service, kind of like
sorry?
platform as a service.
Elastic Beanstalk?
Yeah.
No, I'm talking about that. I'm talking about DynamoDB, Lambda.
Oh
those
yeah.
services,
Okay.
Okay, but
Got it.
but EC2 is not. So it's
Got it,
something that you have to implement manually. But once you do it, the implementation and the configuration is manual, but the implementation is automatic. Okay, when it happens, it will automatically fail over. Yesterday, I was watching Netflix, and all of a sudden, I lost connectivity. Something that says you cannot play this video or movie you're watching or something. It only took about 2 seconds for that to be up and running. 2 seconds. Okay, it's like a hiccup in the system.
Did you hear that Google went down today?
When was what was?
Well, the kids were in session. Never mind. We'll talk later.
So build security into your VPC architecture. Isolate subnets as possible. Choose the appropriate gateway device or VPN connection for your needs. Use firewalls. Okay. Security groups and networks, NACLs, are firewall options that you can use to secure your VPC. Whenever you hear firewalls, that is NACLs and security groups. Okay. One at the instance level and one at the subnet level. Don't forget that, guys. That's very important. So lab 2, video VPC. Do we have time for the lab 2? Okay, we have an hour, right? So I can open that guy. So in this lab, you use Amazon VPC to create your own VPC and add some components to produce a customized network. you create a security group for your VPC. You also create an EC2 instance and configure it to run a web server and to use the security group. You then launch the EC2 instance into the VPC. So this is going to be, you're going to be architecting, guys, architecting in the AWS console. Okay. So the tasks are create a VPC, create additional subnets, create a VPC security group, launch a web server instance. Okay. Now the final product is going to be this one, right? It looks a little weird, but I mean, a lot of things, but it's not. It's not. In probably two stops, probably you can get the whole thing done. Okay. So we have an availability zone A and B, right, inside that region. And then inside the VPC, we have this, the ACs, right? You have one public subnet 1 and private subnet 1 and public subnet 2 and private subnet 2. And then you have this CIDR 10.0.0.0/66 that how many IP addresses can you have here, guys? How many IP addresses?
2,000. I don't know.
65,536. And how about here? How many do we have here available?
256.
251.
251, sorry.
Okay, good. Good. The same here, 251, 251, and 251. We have a NAC gateway here that you're going to implement as well, and the security group here in this web server. Okay, the NAC gateway doesn't need a security group or anything. The firewall is right here in this security group. Okay. So guys, let's begin the lab, and then we're gonna, well, we will never have time to beat the lab either. We have to talk about this guy. Okay? This guy is super important too. So guys, do you promise me that you would do the lab at home?
Yes.
Yeah.
Right?
Yes, for sure.
Okay, so I will open that lab for you guys to do it, right? And then you can go ahead and practice that. Okay.
Florentina and me promise you.
I'm sorry?
Florentina and me promise you.
I don't understand what you're saying, Amaro.
Oh, yeah.
Florentina and Mara will promise you.
Okay. Pink promise?
Yeah.
Okay. So Amazon Ride 53 is a super high level and domain name system, the DNS. That's the DNS service of AWS. Okay. It's a web service. It is used to route the end users to internet applications by translating names, like, for example, www.example.com into numeric IP addresses like 192.0.2.1 that computers use to connect to each other. Guys, computers don't understand www.example.com. They don't understand that. They understand binary. Okay, so remember that the IP address is behind that. There's a binary. There's a bit, right? There's a byte. Remember, each one is a byte. Is number here, right? It has 32 bits. Don't forget that, because a byte has 8 bits, right? So it is zeros and ones, zeros and ones, and zeros and ones. It's fully compliant with IPv4 and IPv6. It connects users' requests to infrastructure running in AWS and also outside of AWS. Right? It's used to check the health of your resources and features traffic flow. Enables you to register domain services. Okay, if I come here to the console and I just type Route 53, this guy here, this is the guy that allows you connect your websites. Okay, so I have a host zone here that I created with this my classroom, that site, right? And as you can see, they also changed the interface of this service. They're constantly changing things, right? So guys, I recommend that you guys keep on top of this, because AWS is constantly changing their GUI constantly. Okay. So we have the dashboard here. You can create a policy, register a domain if you have a domain. Right? You can buy a domain from them. You have different prices here. I wouldn't recommend that because there are better services than this. Namecheap, for example, has a good deals. I'm not advertising Namecheap. I'm just telling you that this is the one that I use. Okay, they have super good prices compared to AWS or any other registrar. Okay. All right, so we have here what happens is just request, you just the user request, just enter this website and a request is sent to the DNS resolver. Okay. Then that DNS resolver will talk to, we checked with Route 53 for an IP address. Route 53 will return an IP address if it exists, right? And then, which is the translation of that example.com, right? And then it goes back to the DNS server and the DNS resolver sends that information to this guy, okay? So that's what happens. That's how it works, right? So this is a basic pattern that Amazon Route 53 follows when a user initiates a DNS request. The DNS resolver checks with your domain in Route 53, gets the IP address and returns it to the user, right? And of course, the machine will understand this guy and the example.com website will be displayed for the user, okay? So there's there are 7, but there's 6 main same supported routing policies, okay? This is something that you have to remember for the exam, guys. And this is what makes Route 53 a super, super duper great user service. Simple routing, you use in single server environments. Just a very simple thing, like any other routing, one-to-one, right? You just put the URL and then you get the information. It's just one-to-one. Okay. Weighted round robin routing, assign weights to resource record sets to specify the frequency. So let's say that you have several servers and then you want to distribute you have 4 servers, for example, you want to distribute the traffic, weighted traffic, right? So you can put 25% for one server, 25% for another server, 25% and 25%. So you have 4 servers just receiving a quarter of the entire traffic. So that's weighted. That's how weighted is used. Also weighted when you have to do some maintenance on a server, you can use that weight round robin routing and just put the weight in another server and leave that one without any traffic so it can be maintained and fixed and updating whatever you're doing there. Latency routing it helps you just put your applications close to your where the services are and the users, and it makes the velocity and the speed much faster, right? Geolocation routing, it routes the traffic based on location of your users. Say that your users are in Japan, so the traffic will be moved to the Japan users using another guy, which is CloudFront, right? So Amazon Route 53 and CloudFront, they work in conjunction. They're a team, right? Because they're both global services and they're just operating at the global dimension, right? The other services there are many services that are local and regional, but these guys are global, okay? So whenever you want to send the traffic to your users, right, to the location of your users, then you can use this routing policy, geolocation routing, okay? Geoproximity routing is the location of your resources. So you will send the traffic from the users based on the location of your resources. Remember, there are some resources that are in a particular region or availability zone. Not all services are available in all regions, and not all services are available in availability zones. So you can use this geoproximity routing, okay, and move the users as close as possible to your resources, okay? Failover routing, you failover to a backup site if your primary site becomes unreachable. So these guys will be also working in the failover operation just in case your site is down. Okay, so this guy, even though it operates at the at the global level, it will be operating just working on the failover operations when your site is down. Now, multi-value answer routing respond to DNS queries with up to 8 healthy records selected at random. This is the opposite of single routing. Single routing is only one. Multi-value is only two. It's more than one. It's multi-value. You have several values, and they're just routed to the same request. It's like when you have, for example, Amazon. In the case of Amazon has different IP addresses. All of them, they point to the same domain. So something like that. You can have several subdomains, and they point to the same domain. You can have up to 8 healthy records selected at random. Okay, at random because they're all the same. It doesn't matter which one is routed to. All these endpoints, they have the same information. Okay. So the main ones are the first 6. They're super common, right? And they might show in your exam, okay? So more on multi-value answer routing. So for example, when you want Route 53 to respond to DNS queries with up to 8 healthy records that are selected at random, you can configure this Amazon Route 53 to return multiple values, such as IP addresses for your web servers in response to DNS queries. You can specify multiple values for almost any record. But multi-value answer routing also enables you to check the health of each resource so that Route 53 returns only values for healthy resources. It is not a substitute for a load balancer, but the ability to return multiple health checkable IP addresses is a way to use DNS to improve availability and load balancing. Okay, so this also has a check to check, if the endpoint is healthy. If it is unhealthy, it will not return anything. It's just returns from the healthy endpoints. Okay. Multi-region development. You have here a user, right? And then you have Amazon Route 53 here. And then you have this elastic load balancer. Because guys, this is a machinery. This is a machinery that is working. All the services are working together as a team, right? This you see here Route 53, but Route 53 is working with elastic load balancers. This says this EBL. That's elastic load balancer. Okay, and this is in the US West 2, and this one is the app Southeast 2. This is Japan. Okay, so we have the Japan elastic load balancer here, and we have, let me say I have a Japanese elastic load balancer and I have an American load balancer here. Okay, so the name is example.com, so it's the website, the same website, right? So we have the alias, you create an alias, and the value is this one. So whenever people type example.com, right, it will send you to the location closer to you guys. Okay, closer to you. So it depends on the location where you are and the routing policy that you're using. Okay. So improve the availability of your applications that run on AWS. This is the DNS failover. What do you have to do? Configure backup and failover scenarios for your own applications. Guys, everything has to be configured by you, right? These failover scenarios and things like that, you have to configure it. Once it's configured, you don't have to worry about anything else. Okay, that's why you have architects, and you have AWS experts that can help you with that. So you can enable highly available multi-region architecture on AWS and create health checks, right? Health checks are looking for a heartbeat. Okay, they don't want to send traffic to something that is not operational. Okay, or from something that is not operational. So that's why they have head checks. Okay, so DNS failover for a multi-tier web applications. When you say multi-tier, you have the front end, the mid, the application here, the logic application, and then you have the back end. Okay, so so you have record sets here, C name, right? Canonic name, www, elastic load balancer, routing policy failover, record type primary. Okay. So you have the primary there, right? And you have the secondary. What is going on here? So the primary, the user's here, right? The user, sends a request. Now we have here Route 53, right? Route 53 using the routing policy failover, right? And then we're gonna come here and the primary. This is when everything is okay, right? Everything is okay. So we come here, and then we're gonna use this guy here. This guy here is gonna send all the traffic here, right? And here we have an Amazon EC2 instance, an Amazon EC2 instance. We have an auto scaling group in the middle, right? That is scaling up or scaling in or out. We have a database here, right? This is a relational database, RDS, right? And we have another relational database here that is being, synchronously updated, okay? Okay. This is synchronous. What's happening here? Okay. So this one will get all the writes, right? And this one will be being updated, right? Now, if something goes wrong, in this case, you have to fail over. What's going to happen? You have a static website here, right? And then it will immediately fail over to the secondary resource type, right? And then here's going to show a static website while you guys are working on whatever went wrong in the primary site. All right, that's how it works. This guy here, Amazon Route 53, it's implementing a failover routing policy when the site is down. Okay. This also happens with when you are doing maintenance, right? And also when something goes down. Okay? That's how it works. This will show a static website, fully functional, so your customers will not experience any interruption in the service. So that's a good way to.
That's a DR, right?
A disaster recovery plan. Yes.
How much?
That's it.
Very expensive?
This expensive? Well, Route 53 is a little pricey because that's a global service, and when you get to the global level, that's kind of a luxury. Okay. But if you're working at the global level, it means that you have a great company, right? Because if you have a small company, you don't need these guys. At least CloudFront. CloudFront is for heavy duty traffic and companies, major companies. So whatever questions you have, guys, as a business owner, you can clear that up with a solutions architect. Everything depends on the business needs, whatever you need. They have plans for everybody, for every company. Okay. And this is just a little overview of how that happens. Okay. How failover for multi-tier web application happens. Okay. So
but I do see many companies using the cloud as a disaster recovery type. They want to put something there that
they have this is how you fail over and then you start working, but you may lose some data here, right? When you do this, right, there's going to be responses and requests and responses here, and there's a database here, right? There's a database here. So you don't want to lose data, so you have to have some RTO and RPO there, okay? And there's some disaster recovery services like pilot, standby, okay, disaster recovery, AWS. So you have some backup there, solutions for disaster recovery, like, let me show you here, one moment. Oh, okay. Oh, that's not what I want. Amazon disaster recovery. Oh, these are third-party websites. I need Amazon Docs. I need the Amazon Docs.
New white paper.
Yeah, but that's okay. Let me see that. This guy has a lot of videos, just in case you want to check out this guy. He has a lot of videos on AWS. So I strongly recommend subscribing to the
Because
AWS.
now one of the biggest I think companies have is the concern of having to purchase hardware and data center space for DR, and they use it only once every 6 months. So to them, the cloud becomes that, less expensive option.
Yeah. So they have several multi-site. They have multi-site. They have multi-site recovery planning. They have standby recovery planning. They have pilot, and they have another one that I don't remember now. But they have like 4 different plans that you can adopt. Of course, the faster you can recover, the more data you can recover, the more expensive it is going to be, of course. And the shorter the RTO and RPO, the more you have to pay as well. So the point objectives, the recovery point objective, or the recovery time objective, those guys, the smaller they are, the more you have to pay. Okay. Yeah. One is for all the data that you can afford to lose, right? And also all the time that you can be down. Okay. And those are questions that should be asked when architecting. Okay. How much are you willing to lose? How much time are you willing to be down? Okay. Things like that. Okay.
Thank you.
Yeah, and now AWS came up with this service, Cloud Endure, which is for a disaster recovery, and it's continuously replication machines, including operating systems, system state configuration, database, application, and files, into a low-cost staging area in your target AWS account and preferred region. In the case of a disaster, you can instruct Cloud Endure disaster recovery to automatically launch thousands of your machines in their fully provisioned state in minutes. By replicating your machines into a low-cost staging area while still being able to launch fully provisioned machines within minutes, Cloud Endure disaster recovery can significantly reduce the cost of your disaster recovery infrastructure. So this is a tough guy. Okay, let me put this on Slack. So guys, probably you want to read more about Cloud Endure.
You are building it in a low cost like type tier, right?
Yeah.
So you know that once you have a disaster, you're not going to be optimally, at the same level, because they're putting you in a lower tier, right?
Yeah. And I've heard that many companies that are using Cloud Endure right now.
They are or they're not?
They are. They are.
That's what I feel, if you're only going to need it in case of an emergency, it's not like you're going to be on that emergency forever. You can always migrate back to your environment once it's fixed. But
yeah. Amazon Route 53 is a highly available and scalable cloud DNS web service that translates domain name into a numeric IP address. Amazon Route 53 supports several types of routing policies. Remember, there are 7. Okay. Can someone mention some of them? Some of the routing policies? Yes, no, maybe, perhaps.
That.
How about single routing? How about waiting robbing? You know, round.
Failover routing.
How about latency? How about geolocation? Okay. How about multi-value? How about failover? Geo-proximity. Okay, guys, you have to remember that. Okay. So multi-region deployment improves your application's performance for a global audience. You can use Amazon Route 53 failover to improve the availability of your applications. Okay. Amazon CloudFront, and this is the last guy that we're gonna see today. Okay. So content delivery and network latency. You know, guys, when you send a request, right, there are gonna be a lot of hops in the way, right? So those are routers that are gonna be in the middle, routers, and then you can do that, you know, hop, right? There's some commands that you can use for that. You can use trace route. Trace route is gonna give you all the in Linux, I think it is, in Windows, is tracert. It's gonna give you all the hops, how many hops, just the number, how many hops are in the way from that place to the other, okay? So you're gonna have a lot of latency, right? You may have a lot of latency because there's a lot of, you know, I would say little interruptions in the way, right? So this guy is global, just like Route 53. It's a globally distributed system of caching servers. It uses cache locations to cache the information. Caches copies of commonly requested files, static content. Why? Because it has an S3 bucket as the origin, static content, right? Remember, you can host static content in an S3 bucket. It delivers a local copy of the requested content from a nearby cache edge or point of presence, right? And accelerates delivery dynamic content, improves application performance and scaling. Okay, these guys, alongside 53, Route 53, they work super well, and they make your application super highly available. You know, Route 53 working with the 6 routing policies and CloudFront working with caching locations, that's super highly available. And the latency is super low. Okay. So we have CloudFront here. It's fast, global, and secure CDN service. Okay, content delivery network. Okay, global network of edge locations and regional edge caches. Service model and pay-as-you-go pricing. So you pay for what you use, right? If you don't use it, you don't pay for it. Okay, it's a little pricey, so it's not cheap. Okay, so this is very fast, like we said before. So Amazon CloudFront is different from traditional content delivery solutions. There's a lot of content delivery solutions. Okay? Why? What does it make it? What makes it different? Okay, it enables you to quickly obtain the benefits of high performance content delivery without negotiated contracts, high prices, or minimum fees. Like other AWS services, Amazon CloudFront is a self-service offering with pay-as-you-go pricing. That's one of the models of the pricing in AWS. You pay as you go, okay? Now you have edge locations, multiple edge locations, and regional edge locations, right? So we have here the locations. It's this map here. This is very updated, right? What is an edge location? It's a network of data centers that CloudFront uses to serve popular content quickly to customers. They're gonna be close to your customers, and they are the blue ones here. There's a bunch of them, okay? The regional edge cache is their CloudFront location that caches the content that is not popular enough to stay at an edge location, okay? It is located between the origin server and the global edge location, okay? So most popular content is right here in edge location. Less popular content is going to be regional edge caches. Okay. But you see, it works with two different, you know, caching places, right? It's fast and global, security at the edge, highly programmable, and by the way, CloudFront has DDoS protection as well. Okay, so it has a lot of security. Right? So by security at the edge, what it stands for is a CloudFront provides both network level and application level protection. Your traffic and applications benefit through various built-in protections, such as AWS Shield standard. So it has Shield. We talked about Shield already. And it's free. Shield is free because standard is free. The one that is not free is advanced, right? So you can also use configurable features such as AWS Certificate Manager. So you can put a certificate manager to the website to create and manage custom secure sockets layer SSL certificates at no extra cost. So CloudFront includes certificates, SSL certificates, which is a good thing. It's highly programmable because Amazon CloudFront features can be customized for specific application requirements. It integrates with Lambda Edge, which is a global service as well, so that you can run custom code across AWS locations worldwide, which enables you to move complex application logic closer to user to improve responsiveness. The CDN also supports integrations with other tools and automation interfaces for DevOps, just in case you're a developer. It offers continuous integration and continuous delivery CI/CD environments. So it's deeply integrated with AWS. It means that it's integrated with AWS with both physical locations that are directly connected to the AWS global infrastructure and other AWS services. You can use APIs or the AWS Management Console to programmatically configure all features in the CNA. And it's cost effective because it has no minimum commitments and charges you only for what you use, okay? Amazon CloudFront avoids the expense and complexity of operating a network of cache servers in multiple sites across the internet. It is cost effective compared to other CDNs, right? But still, it is a little pricey when you see it, okay? In AWS. But compared to other services, because CDNs, they are pricey, whatever they are, right? But AWS is a cheaper option compared to other CDNs. Amazon CloudFront pricing. So data transfer out, that's one of the ways that you're charged in AWS, right? So charge for the volume of data transfer out from Amazon CloudFront edge location to the internet or to origin. Okay? HTTPS request, you charge for number of your HTTPS request. Okay? Invalidation request, no additional charge for the first 100 paths that are requested for invalidation each month. Thereafter, it's 0.005. That is that. Okay.
So quick question. This is Internet of Things, right? This is all these devices that are grabbing tons and tons and tons and tons of data, right?
Yes. That's correct.
Do we get a discount?
Well, you have in AWS, the more you purchase, the less you pay. Okay.
The more you.
Yeah. But you can see the first 1,000 paths are just, free. And thereafter, look at the price.
0.005.
0.005 per path.
Okay, that's not that bad. I was freaking out. I was like, oh my Lord.
No. AWS is super cheap compared to other providers.
Oh, yeah.
So, dedicated IP custom SSL, then you're going to pay $600 per month for each custom SSL certificate that is associated with one or more CloudFront distributions that use the dedicated IP version of custom SSL certificate support. Guys, whatever in life that you see the word dedicated is going to be expensive.
Expensive, yeah.
Yeah, whatever you see it, because that's only yours. Okay, for you only, dedicated to you with a lot of support. Okay. So what is a CDN? It's a globally distributed system of caching servers that accelerates delivery of content. Amazon CloudFront is a fast CDN service that securely delivers data, videos, applications, and APIs over a global infrastructure with low latency and high transfer speeds. It offers many benefits. Okay, you can deliver videos, applications, pictures, so many things with CloudFront. And the good thing about this is they're gonna be cached in local locations, right, for the customer to access them real quick without any latency or very low latency. Okay, thanks to the edge location and regional location and local locations. So wrapping up, right? So in this module, you learn how to recognize the basics of networking. We talked about networking. We talked about VPC, subnetting, IP addresses. We talked about VPN, site-to-site VPN. We talked about direct connect. We talked about transit gateway. We talked about VPC peering, VPC sharing. We talked about regions and availability zones. We talked about public subnet, private subnet. We talked about night gateways, internet gateways. We talked about virtual private network gateways. We talked about customer gateways. We talked about VPC endpoints. We talked about so many things tonight. Okay, and believe me, this curriculum has been enriched. Before, it was not this ample and broad. So AWS has made this better. It has, added more content to the Cloud Practitioner exam preparation. Okay. I believe that this is as advanced as it gets. I don't think it's going to get any more advanced than this. But guys, just go over this. This is important for your exam. And believe me, your exam is in 2 weeks. Okay? Is right around the corner. Right? So we describe version networking in the cloud with Amazon VPC. We said that VPC is free, right? We also talked about firewall and what are the firewall options that we have in a VPC. What is it? What are the firewalls that we talked about? No.
The security groups and the
Security groups and
no,
it's an acronym. It's an acronym.
not
NACLs.
ALC something.
NACLs.
Thank you.
Good, good. Thank you.
Thank you.
We had an exercise in the network diagram. We just answered the questions that they asked us. We didn't design a basic VPC architecture, but you're gonna do it in the lab. Okay. We indicated the steps to build a VPC. Some of the ways that you build the VPC. I created a little one. I just created one in my account, remember, and I created 4 subnets, right? We identify security groups. We created. You're going to create your own VPC and added additional components to it to produce a customized network. We identified the fundamentals of Amazon Route 53, and we talked about the benefits of Amazon CloudFront, right? We spoke about all this in class, a lot today. Okay. Now, does anyone have any questions before we just answer this question?
No.
No? Okay, Which AWS network service enables a company to create a virtual network within AWS? Come on, guys.
It's on VPC.
This is a question that my 2-year-old daughter can respond.
What should be?
Yeah. Amaro, do you know this answer?
I know. I think is how should be?
You need a minute to think.
What should be?
So the answer is Amazon VPC. Okay. What are the keywords here? What are the keywords? Networking
Virtual
service,
network.
networking service, and virtual network.
Virtual.
Okay. The answer is right there. The only virtual network service is VPC. Okay. Yes, within AWS Cloud, because if you think it carefully, Subnet is a virtual network service as well because it is inside a VPC. So be careful with that. Okay. And I thank you for listening to me for 3 hours.
Thank you.
Okay, guys, do you have any questions? I want to make sure that everybody has access to a cloud group. Okay.
Can you give us access to the lab?
Yeah.
I'm sorry?
Can we get access to the lab?
I'm going to open it right now. Guys, maybe some of you were not at the beginning of the class, but these are, I believe, all the students that gave me their email to make sure that you guys received the cloud guru. This access was given to you guys on Monday. Okay, and what I'm concerned about is that you only have 11 days left to use it. So I'm not sure if this is 11 days left to use it or 11 days to accept the invitation. I'm not sure.
I think it is accept.
Either
Because,
way, I would recommend to accept it as soon as possible. Okay. So guys, I believe that all the people that asked me for access, they're here. They're here. So check your email. See your email here. Your email here that is included. And what I have it here. And make sure that you check your spam folder or your junk email folder. Okay. I'm going to go ahead and just give you guys access to just enable the lab. Okay.